Night has fallen on Rocket Lab Launch Complex 1, the world's first private orbital launch site. Our Electron rocket is standing tall and ready on the pad in Pad B in Mahia, New Zealand, as we count down to today's launch for NASA. Thanks for joining us for our 48th Electron launch and our 6th mission of the year, scheduled for liftoff at 19:28 local or 7:28 UTC. It's bright and early for our Eastern and Pacific viewers, with a liftoff time set for 03:28 Eastern and 28 minutes past midnight Pacific. My name is James Rattray.
And I'm Kim Thompson. We're looking forward to another liftoff tonight for NASA. Today is the first of two back-to-back launches on Electron that we're undertaking for NASA's PREFIRE mission, a climate change-focused mission to measure heat loss from the coldest regions of our planet. NASA loves an acronym, so PREFIRE stands for Polar Radiant Energy in the Far Infrared Experiment, which describes the mission objectives for these spacecraft to detect how much thermal energy escapes the Arctic and Antarctica into space. We're supporting this NASA mission with two dedicated launches on Electron to carry one satellite each to a 525-kilometre low Earth orbit on a polar trajectory so that the satellites can travel across the polar regions to make their heat loss measurements.
That's right. Today's Ready Aim PREFIRE launch will set the stage for the second mission, where it will deploy the second PREFIRE satellite on a similar trajectory, but along a slightly different path to overlap with the PREFIRE 1 every few hours near the poles. So what's all of this got to do with climate change? Well, the amount of heat energy that Earth receives from the sun should ideally be balanced out by the amount that Earth radiates back out into space. The difference between those energy levels is what determines Earth's temperature and influences its climate.
Extreme storms, flooding, and coastal erosion are all examples of what can happen based on what's going on in the Arctic and Antarctica. To be able to better predict climate change, scientists need a full understanding of the heat-energy balance happening at the poles, which is exactly the type of data that PREFIRE is aiming to provide. For more about the mission, here's NASA.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
PREFIRE is going to fill this important gap.
PREFIRE, Polar
Radiant
Energy
in the Far
Infrared
Experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. PREFIRE will be deploying 2 CubeSats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our PREFIRE CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow. And what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths. And that's what the spectrometer does. It spectrally separates the radiation into different wavelengths.
These wavelengths were going to give us really important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite comes along and measures the scene over the poles. And then a few hours later, we have the second one come along in a different orbit and measure the same scene, so you understand the impact of how the energy changes in those few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get. And that temperature difference between the warm tropics and the cold polar regions is actually what drives the entire weather system around the planet.
What we want to do with PREFIRE is we want to take these new observations that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be affected by that.
You really can pull off big science with small satellites. This is another great climate change mission by NASA that we can't wait to see launch on Electron.
And all stations, we have held the count at T-minus 12 minutes. Please await further instruction once we get some good data on this winds.
As we just heard from the launch director there, we have entered a hold at T-minus 12 minutes to do with ground winds. We'll sit with mission control and we'll listen out for an update on those conditions. For those of you just joining us, as you can see in the top right corner, the launch director has called a hold at T-minus 12 minutes for ground winds. Happily, we have about 30 minutes left in this window. Our last attempt is 8:04 p.m. local time, so we have plenty of time to let those winds fall within bounds. If you've just tuned in to today's webcast for the launch of Ready, Aim, Pre-Fire, you'll notice that the countdown clock has stopped ticking. That's because we've entered a hold at T-minus 12 minutes due to high ground winds. Now, today's window is about 30 minutes long, so we've got plenty of time to wait for them to fall within bounds, but unfortunately, we are at the mercy of the weather, so there's not a whole lot we can do about it. But let's keep listening in to Mission Control for updates to see how that wind is trending. Okay, the clock is still held at T-minus 12 minutes while our launch director establishes a new T0 time based on those pesky ground winds. Not the same pesky upper-level winds that we often see in the space industry that prevent us from launching. Pesky ground winds today. We do have about 25 minutes remaining in the count here, remaining in the window. So there's still plenty of time for those to come well within bounds.
All stations LD on mission. We're going to resume the count very shortly here. Please be prepared for the go, no go poll and raise any issues you foresee immediately. VCon LD mission.
LD VCon.
Can you please resume the count at this current time?
The count is resumed.
Okay, all stations LD on mission. Proceeding with the go, no go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon's go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
And MM.
MM is go.
LD SUP.
LD SUP is go.
Okay, all stations, the go, no go sequence is now complete. We are T-minus 11 minutes and 8 seconds and counting. We're go for terminals count auto sequence at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect. And just one note for all stations that we are still tracking these ground winds, so be prepared in case we need to hold.
Well, there we go. That is greens across the board for our go, no-go poll, and the team is ready to proceed with all remaining launch operations. As you heard the launch director call out as well, we have a liftoff time for Ready, Aim, Pre-Fire set for 19:41 local time, now in less than 11 minutes.
Today's launch for NASA's PREFIRE mission is the first of 2 back-to-back launches on Electron that will fly out of LC-1. But, in a bit of a coincidence, this time in May last year, we had the first of 2 rockets on the pad for back-to-back launch. Today's launch for NASA's PREFIRE mission is the first of 2 back-to-back launches on Electron that will fly out of LC-1. But, in a bit of a coincidence, this time in May last year, we had the first of 2 rockets on the pad for back-to-back launches for another NASA climate science mission, the Tropics mission, to monitor for hurricanes and tropical cyclones. Now, on our 36th and 37th launches, we deployed 4 storm-watching satellites to low Earth orbit that are helping weather researchers learn more about how environmental factors are contributing to the intensity and structure of hurricanes.
Stage 1 igniter pressures verified, hydraulic pressures verified. LDGC mission.
This animation from NASA shows data that the Tropics satellites collected for some of the first storms of the Eastern Pacific hurricane season last year. Across nearly 24 takes by the Tropics satellites at the time, what you're seeing here is data that shows the evolution of Hurricane Adrian's storm clouds as it developed near the west coast of Mexico but moved away from land. Our 2 launches for the Tropics mission were a great example of how we support important science causes with responsive launch on Electron that gets satellites to exactly where they go. We caught up with mission manager Rebecca Sutton to take a look back.
So last year in May of 2023, we launched 2 effectively back-to-back Electron missions for NASA Tropics. The payloads on these missions were climate change payloads monitoring hurricane patterns. And for PREFIRE, we're also doing 2 effectively back-to-back missions with 2 separate Electrons, going to a bespoke orbit with climate change spacecraft. PREFIRE specifically will be monitoring the far infrared waves over the poles, which helps us gather data on ice melting and heat releasing into the atmosphere and better predicting climate change patterns. We have to be responsive both from a hardware perspective and from a mission design perspective. Tropics needed to base their second mission design on the first, and that was us being responsive after that first launch. But to have 2 rockets fully available and tested ahead of time, I think was quite a feat for the team, both on Tropics and for PREFIRE. We've got all the hardware there before the first mission has launched. We do have a long history of hitting our orbital insertions quite accurately, and especially for things like PREFIRE, where that inclination change is very, very small, that's really hard to hit. And so we are confident in getting that small but very important target for the customer. The team at Rocket Lab loves these science missions that are pertaining to climate change. That's really a global effort, and I think a lot of the team feel very connected to these science missions because they know that they're helping the world as a whole.
We're excited to be routinely launching payloads for the growing science community around the world.
All right, taking a look at the clock now, we're at T-minus 7 minutes and 20 seconds into the count. All is going smoothly so far across launch operations, just tracking those ground winds. The team is ready, the payload is ready, and Electron is ready for today's NASA PREFIRE launch. Today's mission marks our 48th launch, with our next PREFIRE launch after this one bringing us just shy of 50 Electron launches. Our pace for Electron launches every year has accelerated since our first mission in 2017, with almost every year since becoming a record year of launches compared to the one before. Ready Aim PREFIRE will launch on a southern trajectory at a 97.5 degree inclination to a 525 kilometre low Earth orbit. The vehicle you see on the pad there is an 18-metre 2-stage to orbit rocket made of carbon composite material throughout its main structures, which is what gives Electron its black appearance. Apart from its looks, of course, carbon composite construction helps to decrease Electron's mass by as much as 40% compared with traditional aluminium structures. Weighing about a tonne in dry mass, once fully fueled with its liquid oxygen and kerosene propellants, Electron reaches a liftoff mass of 13 times that to get the rocket and its payloads through Earth's atmosphere and into space.
Powering that first stage are 9 Rutherford engines, each of them 3D printed and powered by batteries. With individual capability of up to 5,600 pounds of thrust at sea level, combined, the 9 engines produce around 50,600 pounds of thrust to achieve liftoff. Once Electron has made it to space, its separation system employs pneumatic pushes to separate the first stage from the second, which has a single space-optimized Rutherford engine that powers the mission the rest of the way to orbit. Shortly after the Stage 2 Rutherford engine lights up, Electron separates its fairing, or nose cone, which you can see at the top of the rocket on your screen. This is what surrounds and protects NASA's satellite aboard our orbital transfer vehicle called the kick stage.
That's right, the kick stage is designed to enable all sorts of mission requirements, including deploying payloads at multiple planes and inclinations, and higher altitude deployments and trajectory changes, which we demonstrated last launch. This innovative little platform has an engine of its own called Curie that's capable of multiple restarts on orbit, and which can perform orbit raising and lowering maneuvers depending on the mission. For today's first PREFIRE launch, though, Curie will light up to circularize the kick stage and its attached satellites once it's been dropped off to its staging orbit by Electron's second stage.
LD, GC mission.
GC, LD.
ECS is disabled, pilot auto sequence is armed.
And just like that, we are now pressurized and ready for launch. And then it's through to T-10 seconds, pressurized and ready for launch. And then it's through to T-10 seconds and the countdown to liftoff by our launch director. We're going to hand it over now to Mission Control to listen in on those calls.
All stations LD on mission. From now, there should be no red flags on your critical LCCs. VCON LD mission.
LD VCON.
Lock auto sequence and confirm.
Confirmed, locked.
And confirm all expected primary flows are green.
Confirmed, all ASCOs are green.
And all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge is enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
And with that, we have liftoff from Launch Complex 1 of our 48th Electron mission. Ready Aim Pre-Fire is in the air and on its way to space with its NASA payload. Soon we'll be hearing the call out for Max Q, otherwise known as maximum aerodynamic pressure, which is the point during Electron's ascent where the structure is under the most amount of stress. We'll hear from the GNC operator shortly that Electron has cleared that milestone.
High voltage battery discharge is nominal.
Cleared Max Q.
And that was the Max Q milestone, passed cleanly through by Electron as it carries on its mission now at over 18 kilometers in altitude and moving at over 2,400 kilometers an hour. Next up will be 3 actions that are performed by Electron back to back to back. The first is main engine cutoff on the first stage, when all 9 Rutherford engines will shut
Guidance
down.
is nominal.
Next is stage separation, when the booster disconnects from stage 2. And then we will have second stage engine ignition, when the Rutherford engine on the second stage lights up to carry on with the mission. Those call-outs should be heard as MECO, stage separation, and second stage ignition. Let's listen in now.
Stage 1, propulsion holding nominal, standby for MECO in 30 seconds.
$15 seconds to staging.
Entered burnout detect mode. MECO confirmed.
Stage separation successful.
Stage 2 ignition confirmed.
MECO, stage separation and engine start on that second stage. Electron is sailing smoothly through space so far. Now, that red-hot engine nozzle that you see on your screen is what's powering
Guidance is
Electron's second stage, past 105 kilometers in altitude and 8,350 kilometers an hour.
High voltage battery discharge nominal.
Now, although Electron is moving at over 7 times the
Stage 2
speed of
propulsion
sound, there's
nominal.
very little resistance in the vacuum of space. So the next major milestone coming up is fairing jettison, where the two halves of the rocket's nose cone will separate and fall back to Earth. On missions like this, where the payload is a tiny portion of our overall mass, we leave the fairing connected for a little while longer than usual. Now, we should see that fairing jettison occur just after 4 minutes, and hopefully we'll get a good shot of them separating and falling on their way back to Earth.
Fairing jettison succeeded.
And that there was the call out for fairing jettison, confirming that the nose cone on Electron has split apart and fallen away in preparation for NASA's PREFIRE satellite to deploy.
As you can see, we're at T plus 4 minutes and 41 seconds. Electron is travelling at speeds of 10,800 kilometres an hour and at an altitude of 174 kilometres.
Stage 2 propulsion nominal.
We're now coming up on the moment when the second stage Rutherford engine needs to perform its next action, a manoeuvre called the battery hot swap. This is a move unique to our Rutherford engine. Since its pumps are powered by batteries, by this point in the journey, we need to swap out the draining battery packs for a fresh set of new ones that will keep the engine running. The old batteries will be ejected, and you can usually see that happen on your screen. So keep an eye out on the shiny object on the right of your screen just after 6 minutes into the mission.
Hot swap successful.
Another milestone down, that was battery hot swap for the second stage Rutherford engine. All is continuing nominally for Electron, its engine and the mission as we carry on past 210 kilometres and 18,000 kilometres an hour. It will then be some of its last, the kick stage and NASA's PREFIRE.
HVV battery discharge holding nominal.
T plus 7 minutes 46 seconds into this mission. The engine that you see on your screen is Electron's Rutherford engine. Now, as Kim mentioned before, the sea level version of that engine is capable of 5,600 pounds of thrust, and the vacuum version you see on your screen now is capable of 5,800 pounds of thrust. Now, Electron's total at liftoff is about 50,600 pounds, and compare that to a single Archimedes engine for our upcoming Neutron rocket. The single Archimedes is capable of 165,000 pounds of thrust, which is the equivalent of 3 entire Electron rockets or 27 Rutherford engines on their own. It's now T plus 8 minutes and 30 seconds. That means we're coming up to the second stage engine cutoff for this launch, which is an action very similar to separation earlier in the count.
Welcome back to the webcast of Rocket Lab's 48th Electron mission called Ready, Aim, Pre-Fire. Earlier this evening, Electron lifted off of the pad from Launch Complex 1 with its NASA satellite on board for its pre-fire mission, a mission to monitor the heat loss to space from the Arctic and Antarctica to better predict climate change. After completing all the usual mission milestones like max Q, stage separation between stages 1 and 2, fairing separation, and stage separation between the second stage and the kick stage, we are now at the final moments of the mission before our kick stage deploys the NASA satellite to space.
Just now, the kick stage has reached its 525-kilometre apogee above Earth. The trajectory it was delivered to is an elliptical orbit, which means that the kick stage and its satellite were moving in an oval shape around Earth instead of a circular one. But moments ago, the kick stage lit up its Curie engine to place the kick stage and NASA's payload on a circular path. This course correction engine burn lasts for just under a minute, and we're coming up to that point when the engine is due to shut down. So let's listen in to mission control for confirmation.
Stage 3 propulsion is nominal. Curie engine cutoff confirmed.
There we go. That's engine shutdown of the Curie engine on the kick stage. We're now less than a minute from payload deployment of NASA's PREFIRE 1 payload to detect how much thermal energy escapes the Arctic and Antarctica into space. After this launch, we'll be back on the pad in the coming days where the second PREFIRE satellite joins its colleague in space.
PREFIRE 1 deployment confirmed.
There you have it. The kick stage has successfully deployed NASA's PREFIRE payload. Congratulations to the Rocket Lab team on another mission success for Electron. And to NASA, welcome to space for the PREFIRE mission. We can't wait to be back on the pad with you again soon for the second PREFIRE launch on Electron in the coming days.
With only a few days until the next launch and then Electron's 50th flight shortly after that. It's crazy to think we lifted off the pad for the very first time 7 years ago. In fact, 7 years to the day, May 25th, 2017. For now though, we'll say goodbye and we'll end the broadcast here, but keep across our social media channels for all other updates about Rocket Lab and our upcoming missions.
Until next time, thank you so much for joining us for today's launch. This is Rocket Lab Mission Control signing off.